Our first presenter, Fawna Korhonen, is GSWA's Manager of Proterozoic Margins. Fawna has expertise in metamorphic geology, tectonics and geodynamics. And she leads a team at the Geological Survey in the acquisition of pre-competitive data in the Western Australian Proterozoic age terrains. Thanks, Fawna.
Thank you and good morning. Wonderful to see you all here. Before I begin, I would like to pay my respects to the traditional owners of the land on which we meet today and to acknowledge their enduring connections to water, land, and sea. All right, so I've been with GSWA now for more than 10 years. Whoops. Why am I having trouble, Sabrina? It's going, oh, the big green button. Big green button. Okay, so I've been here for a while now, but in a previous life, before I came to Australia, I was a researcher in the US with a strong focus on Antarctic geology. And I was involved with the US Antarctic program during the 4th International Polar Year. Polar years are infrequent but really significant research collaborations between multiple countries to better understand polar regions. And a flagship project of the 4th International Polar Year was the study of the Gamburtsev subglacial mountain range, which is an alpine-scale mountain system completely buried beneath the East Antarctic ice sheet. Now, I wasn't involved in this work at all, but I was completely fascinated as to how we could access and better understand hidden geology undercover, in this case, 2 kilometers of ice. Well, fast forward now 15 years later, and here I am in Western Australia with my own opportunity to access hidden geology undercover in a slightly warmer place, now in the frontier of Western Australia, the Gap. Okay, so for those of you that don't know, the Gap is the region of the eastern and central deserts, shown here on 2 different scales of map. And it is highly prospective for a range of commodities. And that's kind of hinted by the occurrence of known mineral deposits and mines that surround the Gap. And this isn't particularly surprising because the Gap is also the nexus of several craton margins, which is shown on the map on the right on the very hard to see orange dashed lines. Okay? And we know craton margins to be quite favorable tectonic settings for a range of mineralization styles. So things are looking good for the Gap. But I probably don't need to tell most of you here the Gap is quite a challenging place to work. It's remote, and it's also covered by extensive sedimentary and regolith cover. And therefore, it is quite data poor. And this is really well illustrated, this data poor nature of the Gap, by the recent heavy mineral map of Australia that was just published this year by GA and Curtin. And other data sets will show a similar sort of thing, but look where the data gap is. It's in the Gap. And so a major strategic objective at GSWA is to better understand the geology undercover in the Gap. And not just through geophysics, as great as it is, and remote sensing, but we want to be able to obtain physical samples where we can. So there's 4 key areas that we've identified in the Gap that we are going to be working on, and I'm going to briefly introduce today 2 of them that we hope to get some data on in the next year. Okay, so before I delve into our NDI areas, I would like to mention that GSWA is a key participant in the MINEX CRC National Drilling Initiative, which manages and delivers multiple drilling programs across the country in collaboration with state surveys. And a key component of the NDI is to develop and test the coiled tube drilling technology and associated downhole sensing. Okay. Now, this really is a research-driven program using prototype technology. There's one 500-meter CT rig that's currently in operation, and you can visit its digital twin just out there in the foyer. And there's also a 1,000-meter rig that's currently in development. There's a lot of other benefits to CT drilling that I'll kind of elaborate on in the next few slides, but what I'll point out here is that, as you can see in the photo, it has quite a small footprint. It's got a very small crew size. It's also on tracks, so these things make it quite mobile and quite easy to move around. It also uses far less consumables, as I'll demonstrate in the next few slides. Okay, so our first NDI campaign kicked off in August in the Patterson region in Northwest WA at the Nifty copper mining lease. And this was the 5th NDI campaign for Minex. So at this point, the CT drill, the CT500, had completed nearly 13,000 meters of drilling before it came to us. The drilling plan is to drill 10 500-meter holes with the CT rig, a long strike and a cross strike from the deposit, and Simon mentioned some of this today. And so what we're really hoping to do is to get samples to look at the changes in geochemistry, mineralogy, and petrophysics with increasing distances from the deposit as a way to really look at the distal footprint. We're also looking at vertical changes, so we're looking at the sedimentary bedrock, the regolith, and then the interface in between. We are also twinning 2 of the CT holes with existing diamond drill holes, so this will really give us a great opportunity to test this technology in comparison to the gold standard of diamond drilling. So 3 near mine holes were completed in the first phase of the project, and at its best, the CT rig had a rate of penetration of about 11 to 16 meters per hour. Less than 2 liters of diesel were consumed per meter, and about less than 5 liters of water were consumed per meter. So at this point, I think it's worth just talking very briefly about some of the advantages of the CT drilling over more conventional techniques, in particular RC drilling, which has a roughly similar rate of drilling and retrieves a similar type of sample material. Well, I think it's quite obvious here, but the consumables used in CT drilling are far less than what we use in conventional drilling. Therefore, it makes it much cheaper and more environmentally friendly. The estimated cost reduction of CT drilling in comparison to diamond drilling is 1/5 and 1/3 of what you would expect in an RC campaign. That's pretty cool numbers, I think. It also has less spinning parts, there's no rod changes, there's no big air compressors on site, so it's also a safer type of technology. The drilling fluids and the drilling parameters can be optimized for the conditions, which is pretty amazing. And we're also very happy with the sample return and the depth fidelity. And lastly, we can obtain core, 3 meters of core at any stage in the drilling campaign, at any stage in the hole, and even in targeted directions. So these are all very good, very amazing things, but it's really the immense potential for additional capabilities in the future that makes this really exciting. This includes the ability to go deeper. The 1,000-meter rig isn't that far off. The ability to get downhole data and data while drilling to really better inform real-time decisions in our drilling campaigns. And even maybe the ability for the machine to be fully automated in the future so that nobody has to be on site. Okay, so that's all very well and good, but there were some issues encountered that affected our productivity in this first campaign. They're listed here, the most significant being a cracked reel bearing, which is shown in the photo. This is prototype technology, yeah? We couldn't send out a second rig to complete the job. So the rig was decommissioned, or was demobilized and brought back to Adelaide for repair, which is where it is now. But for every issue that we encountered in the campaign, we really did learn something really valuable that will help us in the future. And so there are a lot of positive takeaways from this first phase of the project, but what I really want to highlight here is that the program so far really confirmed our optimism that this is an exciting technology in its very early days, and we're committed to trying to help it reach its full potential as a possibility of adding it to the GSWA toolkit as a way to help us get the next generation of pre-competitive geoscientific data. So stay tuned. All right, our second campaign will be kicking off in the Eucla region starting in January, so just around the corner. This will be the 6th NDI campaign for Minex, and it's really building off of a previous drilling program in the region, including a GSWA stratigraphic drilling program, which we did 10 years ago. There we drilled 8 diamond drill holes. And this upcoming campaign, what we're aiming to do is to drill 3 500-meter holes with the CT rig, but we will be obtaining diamond core along the way. Okay. We're targeting a geophysical anomaly in the Majora province, and we're also inevitably going through the Eucla limestone cover. So because we anticipate this cover to be quite challenging, we are allowing up to 3 attempts per hole. So we could have a campaign of about 9 holes in total, which makes it quite similar in scope to the previous stratigraphic drilling program. In terms of costs, in 2013-14, we spent about $3.8 million on drilling costs. For this CT program with the diamond coring, we have budgeted less than 1.3. So I think that really illustrates kind of the cost benefits to using this technology. In terms of value, there are 3 things that we're really hoping to get out of this program. The first is, of course, geological knowledge in an area that we know relatively little about. The second is information on drilling through this very challenging cover, which we expect will be of great use to other explorers in the area. And thirdly, we want to continue to test the CT technique for future programs, which include, of course, geological investigations, but also maybe even land use assessments, which Simon touched on a bit today and I think will pop up again later. We might need to go into areas relatively quickly and assess their land use potential. We want to do that quickly and cheaply, and this might be a really good way to do it. So to wrap up, in our attempts to unlock the gap, an important objective at GSWA is to access geology undercover, and that includes physical samples. We are doing that with, through the NDI, testing the the CT drilling technology. We've got 2 campaigns that we hope to finish up by middle of next year. That's the Eucla program, where we'll be getting geological data on bedrock and the sedimentary cover, as well as information on drilling through these challenging cover sequences. And then the Patterson, where we're looking at a distal footprint of a major deposit. And lastly, I want to just finish on our optimism on the technique and really its future potential, which sky's the limit. So, thank you.